Hello everyone, and welcome to today's chem lesson. Today we are going to talk about polarity, what it means to be polar or nonpolar, and how we can look at a bond and tell if it is polar or nonpolar, and how we can look at a molecule and tell if it is polar or nonpolar. Now, first, it's important to know that these are only for covalent substances, right? We're only looking at covalent bonds and covalent molecules for this. Ionic things are a separate category in and of themselves and do not fall into this umbrella. When we talk about something being nonpolar, we are talking about something where the electrons are shared equally. If it's a bond, we're talking about a bond where the electrons are shared equally. If it's a molecule, we are looking at a molecule in which the electrons are shared equally. The definition of nonpolar does not change if we look at bond versus molecule. Same thing goes for a polar bond or a polar molecule. When something is polar, the electrons are not shared equally. When we talk about bonds being polar or nonpolar, for a nonpolar bond, for electrons to be shared equally within a bond, we need the same element on either side of the bond. That will make this a nonpolar bond. There are a lot of common examples in the diatomic elements, elements that are naturally found paired up. Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine are all diatomic molecules. That means you will never just find bromine by itself, it will always be, at least, paired up with a copy of itself. Same thing goes for oxygen. Never going to be O by itself, it's always going to be O2 at minimum. These are fantastic examples of nonpolar bonds because it's the same molecule, same atom connected to another copy of the same atom. Quite literally, everything else will be a polar bond. If the two things that are connected are not the same element, you end up with a polar bond. Because there's no way that these two different elements have the same pull, that they pull on the electrons with the same strength. Let's look at some examples here. Let's take a peek at some different molecules and see if they have polar or nonpolar bonds. In this molecule, in this ammonia molecule, are the bonds polar or are they nonpolar? Here in this molecule, we have polar bonds. N connected to H 3 different times makes all of these bonds polar. It's not the same thing. In order for a bond to be nonpolar, we need the same thing connected. If there's two different elements connected, it is a polar bond. What about CH4? Does this molecule have polar bonds or nonpolar bonds? Here again, we have a molecule that contains polar bonds. C connected to H is two different elements connected together. The only time bonds are nonpolar is if it is the same element on either side of the bond. Here you have four different bonds, each connecting a C to an H, two different things. So these are polar bonds. What about in CH3Cl? Are these polar bonds or nonpolar bonds? Here, more polar bonds. Carbon connected to anything other than carbon. Right, C connected to H. I've got three of those, and I've got C connected to Cl. Those are polar bonds. The only time a bond is nonpolar is if it is the same element on either side of the bond. What about the bond in H2? Is it polar or nonpolar? Here we have our first set of nonpolar bonding. This connects an H and another H, which makes it a nonpolar bond. What about HCl? Is this bond polar or nonpolar? Here we're back to a polar bond because H and Cl are not the same thing. We are connecting two different things. If they were both Cl's or if they were both H's, those would be nonpolar bonds. When we look at bonds, we're looking at the identity of the elements on either side of the bond. But when we look at the polarity of a molecule, we zoom out and we take a look at the molecule's shape overall. We're still talking about the same thing, either the electrons being shared equally or the electrons being shared unequally. But when we look at the molecule, we're not trying to look at each bond individually. We're looking overall at the molecule as a whole. And the way we're going to tell if a molecule is polar or nonpolar is by looking at the molecule for lines of symmetry. A symmetrical molecule is nonpolar. Something that has multiple lines of symmetry. And an example of that is carbon dioxide. Carbon dioxide has two lines of symmetry that we can draw. We can draw this vertical line of symmetry and this horizontal line of symmetry through the molecule. And I hear already, Mr. M, that's not right. The letter C does not have a vertical line of symmetry. The left half of this is not the same as the right half of this. And you are correct. The letter C does not have a vertical line of symmetry. But an atom of carbon does have a vertical line of symmetry. Because an atom is a nucleus with electron shells that surround it. And pretty much any angle you cut this at is symmetrical. There's no stopping an atom from being symmetrical. It is a circular thing. When we read these letters, when we look at this C or these O's or these H's, we're not looking at the letters. We're using letters to represent these atoms. So even if the letter isn't symmetrical, half of a carbon atom on the left is symmetrical to half of a carbon atom on the right. Same thing goes with something like bromine. We pull that back out. There are no lines of symmetry in bromine, but I can put a vertical and a horizontal because this set of letters, this B and this R, represent an atom that looks just like this. So a symmetrical molecule, something with multiple lines of symmetry, is a non-polar molecule. That means the electrons in this thing are being shared evenly. On the other hand, something that is asymmetrical, something that has 0 or 1 line of symmetry, is a polar molecule. Water has only one line of symmetry, this diagonal line through the middle here. There are no other lines of symmetry in water because there is only one. That makes this a polar molecule. Multiple lines of symmetry, non-polar. It means the electrons are being shared equally. 0 lines of symmetry or 1 line of symmetry, it's a polar molecule. That means that electrons are not being shared equally. Now it's important to notice all of these bonds are polar bonds. Right? These bonds connect O's and C's. That's not the same thing. That means these are polar bonds. Same thing here. These bonds connect a C and O. Those are not the same thing. That means these are polar bonds. 2 bonds connecting O and H. 2 different things, polar bonds, right? When we look at the molecule, we no longer are focusing in on the bonds. It is a separate thing that we are looking at. A polar molecule has only 1 line of symmetry. A non-polar molecule has multiple lines of symmetry. When we're looking at the molecule, we no longer really care about the bonds themselves. Let's look at some examples here. Is this molecule polar or non-polar? This is a polar molecule. I can only draw 1 line of symmetry in this molecule vertically through the top. 0 or 1 line of symmetry, polar molecule. Multiple lines of symmetry, that's a nonpolar molecule. What about this one? CH4, is that a polar molecule or a nonpolar molecule? Here we have a nonpolar molecule. There are multiple lines of symmetry that can be drawn in this molecule. You can put a vertical, a horizontal, you can even include the diagonals as lines of symmetry. Something with multiple lines of symmetry is a nonpolar molecule. The electrons in here are being shared equally overall in the whole molecule. The bonds, the individual bonds, are all polar. It has 4 polar bonds, but overall is a nonpolar molecule. It's important to make that distinction. We are no longer looking at the bonds. Right now, we're asking about the molecule. Is the molecule polar or nonpolar? Which means we're looking for lines of symmetry. Can I draw multiple lines of symmetry within this molecule? If it's yes, then it is a nonpolar molecule. If the answer is no, if there is only 1, or if there is 0 lines of symmetry, it is a polar molecule. What about this? CH3Cl, is this a polar or a nonpolar molecule? This is a polar molecule. I can only draw one line of symmetry, this horizontal line of symmetry through the molecule. I cannot draw a vertical line of symmetry here, because if I draw a vertical line of symmetry, I'm saying that an H is the same as a Cl, which it is not. So the only place for symmetry in this molecule is horizontally through the middle. One line of symmetry makes a polar molecule. What about H2? What about hydrogen? Is this a polar or nonpolar molecule? This is a nonpolar molecule. We can draw multiple lines of symmetry. We can draw one vertically, we can draw one horizontally. This even has symmetry in the classic sense, where it's literally symmetrical. We're not even worried about letters that aren't symmetrical. This has multiple lines of symmetry, making it a nonpolar molecule. One more. HCl. Is this a polar molecule or a nonpolar molecule? Here, only one possible line of symmetry exists, horizontally through the compound, making it a polar molecule. Now, let's take a minute and let's summarize what we just looked at. We're looking at bonds and molecules and seeing if they are nonpolar or polar. For a bond to be nonpolar, it must have the same element on either side. Right? We want two identical atoms. That makes this bond nonpolar. If a bond is polar, it is two different atoms connected by the bond. Two different atoms means that the pull on electrons is not the same. It means that this is a polar bond. When we look at the molecule, we're still talking about electrons being shared equally or unequally, but we look at the symmetry of the molecule. For a nonpolar molecule, you have multiple lines of symmetry. So any of these are nonpolar molecules because they each have multiple lines of symmetry. So all of these are nonpolar molecules. For a polar molecule, you either have only one line of symmetry, like you have in water, or you have something that has absolutely no lines of symmetry in it. Water has one line of symmetry. This has 0 lines of symmetry. So these are both polar molecules. Polar and nonpolar always mean the same thing. We're looking at nonpolar. It means electrons are shared equally. Polar means electrons are shared unequally. Whether we're looking at the bond or the molecule, that's what we're trying to determine. There's two different ways of determining, either looking at the atoms for a bond or the lines of symmetry for a molecule. And with that, I'm going to transition us over to our Zoom meeting for questions, comments, concerns, and attendance. And I will see you there.